Hello, everybody. Welcome to today's fireside chat, which is future-proof your fleet without touching your hardware. Sounds like an ambitious topic. I am your host. Happy to be with you all. My name is Jim Hassman. I'm the President and Chief Revenue Officer of Blues. I've been with Blues for 3.5 years and joined the founder and CEO of this company, Ray Ozzie, who founded the company back in 2018. And we just had a recent announcement you guys may have seen in the press. We brought on Ian Small as our growth CEO. So Ray is still here as executive chair and founder and chief architect. And we brought Ian in as well to help us in the growth phase of our company. I'll share a little bit about Blues. I'll introduce our guests and allow them to talk about themselves for a little bit, and then their company, Croxel. Um, just a little bit about Blues. I'm just going to share a couple little slides and then we'll get into the content of the meeting. Um, so Blues is a hardware-led SaaS company. Our focus is to help transform every physical product into a data-rich, intelligent service, and we do that by the little blue box you see in the middle of the screen. Our product is a piece of hardware called the Notecard and a piece of cloud infrastructure called the Note Hub. And the Note Card and the Note Hub work in orchestration with each other. They are tightly coupled to pump data from your devices to your in-cloud application. That is our mission, is to make the middle part as painless as possible. And when Ray designed this, if you look at the bottom of the slide here, this is what he was trying to do. Provisioning, communication, security, and update. The update part will be talked about today quite a bit. They just work. They just work out of the box economically and at scale. We have a bunch of note cards. These are the little hardware modules I was talking about. You can classify these as a system on a module if you want to use that term, but they really are part of a larger infrastructure that also includes communications and cloud infrastructure. But we have cellular plus Wi-Fi, we have satellite, we have LoRa, and we have Wi-Fi. If you notice the little bronze um, portion of the note card at the bottom of the note card, that is a M2 edge connector, goes into an M2 slot on your printed circuit board. Why am I calling that out? Well, you can swap these things in and out without having to change your code. So if you're using Wi-Fi in a location and IT won't let you get on the network, just pop a little cellular card in and voila, your device will work without having to change any code. So true multi-radio access capability across these suite of note cards, which is a really cool feature that I think only Blues does. I'm not going to read all the features of the note card. We can talk about some of these in today's fireside chat, but there are a couple items in bold here. Why do people love it? Well, it's easy to use. It's designed for low power applications. You can use main power, that's fine. Um, there are no cellular fees. There's no SIMs. There's no modems to buy. You literally pop the module in and it works. It comes with 10 years of service, which includes 500 megabytes that will recharge when you run out of that. And it works globally in roughly 137 countries with this service. And if it doesn't work in a portion of the world that you're in, you can just pop a secondary SIM in. The firmware will recognize that and the note card will keep working. So really cool module. And the Note Hub. The Note Hub is where you manage your fleet of devices. It's where you set up where you want to route your data to your in-cloud application. And super importantly, this will be part of today's conversation. When you want to do an update over the air, this is the part of the system that helps you do that down to the note card and even down into your host MCU firmware. So we'll talk about that. But those are some general concepts you need to be aware of before we start today. So without further ado, let me introduce our guests. First, I want to tell them how much we appreciate them helping with this fireside chat. These are super fun to do. These hopefully are not slide-by-slide webinars that put everybody to sleep. This is more of a podcast, fireside chat style. We're going to freeform this as we go. We do know each other. We did prepare for this, so it's not like we're coming in unprepared, but we're excited to talk to you all. I'd like to welcome Albert. He's the CEO and co-founder of Croxel, and his colleague Carlos, who's the director of strategic planning at Croxel. I'll turn it over to them to introduce themselves further, and also Croxel and what Croxel does, and then we'll get into the heart of the topic.
Absolutely. Thank you, Jim. Really happy to be here. Thank you, everybody. So yeah, my name is Albert. I'm the CEO and co-founder of Croxel. We started Croxel about 10 years ago. My background, I'm an electrical engineer, passionate about technology, um, mostly building companies, putting together team, working in big ideas. So that was the intention when we started Croxel. And ever since, we've become an IoT product development company. And we work on really cool and interesting projects and products. Um, so, Carlos, go ahead and introduce yourself.
Thanks, Albert, and thank you, Jim. Yeah, very excited to be here too. My name is Carlos Mejia. I'm Director of Strategic Planning at Croxel. My background includes mainly project management, enterprise excellence, and process optimization. I'm the latest team member to join Croxel team, and it's been a great few months since I joined back in April, I think. So very excited.
Probably feels like forever now.
Oh yeah, you have no idea.
So they'll explain a little bit more about the projects that Croxel's involved with. But one thing I'll say to the audience here is that Croxel is a Blues accredited partner, and you might be asking yourselves, what does an accredited partner mean? It means they've jumped through a whole bunch of hoops. They have utilized the Blues technology at a very deep level on active projects that are in deployment. So they are not a newbie to the Blues ecosystem. They're very well versed in using the Blues product and how the Blues product works and how you integrate it into your design and into your connected solution. In fact, we were introduced to Croxel actually by an existing Blues customer that had some problems they needed help solving. And the problem that they needed help solving was pretty interesting. We're going to talk about it today. They wanted to replace the operating system of their device without sending technicians into the field. Kind of an interesting topic. So we're going to talk about that today. This customer is a customer known as Lift AI. Lift AI is a startup company that started several years ago, was founded by a really interesting guy named Rob Worth. Rob came from a family, a multi-generational family that has been in the elevator service maintenance business for generations. And Rob came along and said, you know what, there's this really cool thing called AI out there. Maybe we could pick up some signals from these elevators that would help us better predict degradations in elevator behaviors before they break. We've all been in buildings when the elevator shaft is like closed, it's not working. His company's trying to make sure that doesn't happen, and using a combination of a device that sits on top of the Faraday cage of an elevator and his own IP related to algorithms that run basically on every trip that elevator is making. So that's kind of the background on the customer. That's how we got to know Croxel. And I have a question for either of you. Can you help the audience understand the prior state of the Lift AI device and why they needed Croxel?
Yeah, Carlos, you want to take that one first?
Yeah, absolutely. So I think Jim, you did a great job at starting the conversation around who Lyft AI is. Yes, they're a startup and they've been disrupting the elevator maintenance market the last couple of years. I think one of the main reasons why they looked for help and reached out to us is because in order to make that disruption happen, they had to hit the market quickly. And in order to do that, they came up with a device that, even though was effective for their original intentions, monitoring some data and allowing customers to see different points of data on the elevator's performance to see how they could, provide maintenance to it in advance or proactively. It soon they realized they needed to upgrade. They needed to add more features, or they were starting to find some challenges due to their own growth. And so, right, they said, how do we do this? They had to upgrade the firmware, upgrade the hardware itself, but they had already deployed hundreds, if not thousands, of units across the country. And so there were two main challenges. One, revisions to the new version of the device and the firmware itself, easily enough to do. It has its own set of challenges, but then what happens to everything that's already in the field? And that's essentially what we're talking about today. They presented us with this challenge, and so it led to a very interesting iterating process of how do we accomplish this? How can we, as we call it, brain transplant all of these units, change them from Circuit Python, which was the original firmware stack, to Zephyr RTOS, which is what we used. And yeah, that led to some interesting conversations and eventually some interesting results. I'm sure we'll discuss in the next few minutes.
They were quick to go to market, as every good startup should be, right? So the decision process was geared to, okay, how do we get there fast? How do we disrupt this? We have this idea, we know we can do it. And they build the thing that allows them to do that at that point, right? But at the same time, the thing that get them there fast, they had to compromise some things at the technical system level in order to be out there really quickly. That then became a big constraint when they started to having success and demand, and they needed to grow, right? So that's where we came in.
Yeah, it's an interesting it was an interesting time for them because, can you utilize the Blues over-the-air firmware update techniques versus having to send technicians into the field? Now, that would be a challenge, I would assume, for Lift AI because these elevators are all over the place. And flying people to locations to go literally swap operating systems on a device is extremely expensive. In fact, I did a bunch of chat GPT research on this. I don't know if my numbers are right, but I basically plugged in how many elevators there were out there using these devices, how much a trip would cost, how much labor rates were, troubleshooting time, um, everything down to like transportation, hotel stays, per diems. It probably would put somebody out of business to have to go do this at that stage of a company.
Oh yeah, absolutely. And I can
So
tell you, we learn a lot in the process too. And when we learn how much the elevator technician hourly rate is, I was like, oh man, I think I'm in the wrong line of work.
yeah, well,
Wow,
and
I had no idea.
this is
Yeah.
a specialized job that you don't do every day. I mean, technicians are not changing operating systems out. They're fixing things and doing others. So they would have to be trained and then they go out and troubleshoot and probably learn half of it on the job. But um, can you guys explain a little bit about what you did to help Lift AI solve this challenge of swapping RTOSs?
Of course, yes. So what did Croxel do to solve these challenges? Well, like I said, the whole situation spurred a series of conversations that led us to analyze the problem and come up with solutions. Like I said, there were two main issues, right? So you have the general revisions to the firmware that need to happen for future devices that haven't yet been manufactured, and mainly to what we're discussing today, what happens to those that have already been deployed that are using hardware we cannot change and that are running on a firmware stack that is no longer applicable. So we devised a plan, which involved, of course, the Blues Notecard. We needed to kind of make it switch from, we use these brain transplant analogy, and it sort of becomes into the Notecard was a nurse, and then we with the help of your team, turned it into a surgeon. We essentially used it in order to upload the new firmware stack, which included a whole bunch of changes, it was now in Cepheid TOS, which had a modular architecture, which allowed it to be more future-proof. Hereby, then the title of the presentation, making it more able to evolve. Right? There was this, back when I was in school, I love this analogy of evolution. There's a concept of convergent evolution, right, where different organisms can develop similar features over time, being put under stress by the environment. Coming to this case, it's like you can develop a solution in different systems, Python, Zephyr, etc., and get similar results. But then as the environment changes and new challenges arise, in this case, you need to scale, you need to add new features, fix bugs. Depending on how you got to that point, the device can either succumb to the challenges of the environment and go extinct, which was the original case of the initial device. It served its purpose, or it can have the tools necessary to evolve and manage the circumstances, and that's what we wanted to do. And so that's how we approached it. We wanted to not only provide a solution for what was coming next, but also what was already deployed, give it its opportunity to evolve, utilizing the note card as a surgeon that could, essentially remove what was already in the firmware stack for the main chip, and then put the new firmware there from the ground up.
So let me see if I got this straight. The prior operating RTOS was Circuit Python. It was sitting in the Lift AI's host MCU.
Yes.
And you guys used through Note Hub down through the note card, basically did this brain surgery from the note card into the host MCU and replaced the entire operating system for the device. And what would have happened if that didn't work and you guys were in the middle of that brain transplant and like something like bugged out on you? What would the situation would have? I mean, would you had to fly in a technician out?
Albert, do you want to follow up?
Yeah, the process, usually whenever we do a over-the-air device firmware update, right, we try to do it in a manner that there's a fail-safe mechanism, right? So there are a few checkpoints that we can hit. If something goes wrong, then we can try to revert the process. Most of the time, you come back. Sometimes things happen. There are the weird edge cases. There are a point like we might be able to say like we maybe we can't reach this device remotely, and the only solution in that case would be somebody needs to go and retrieve it. But fortunately, it didn't happen here. We had 100% success rate on the complete fleet. Yeah.
100% success rate. And how much downtime on the devices?
On the devices itself, the whole process takes about 15 to 20 minutes, depends on how the cellular signal strength is in the place. But fortunately, this process can take, if the signal is really weak, it will take a little bit longer, but it'll go through. But I think the more interesting metric is it was zero downtime for the elevator. So I suppose that if you had to ship somebody or somebody has to go there and work on it, they have to shut down the elevator completely. So the actual operation gets disrupted. In this case, they didn't even notice. People could go in the elevator and use it up and down and nothing changed. Right?
You did brain surgery on all of these elevators, and the elevator was still kicking and breathing and working.
Yeah.
Had
We did the
100%
brain change on the Lift AI device, which sits on top of the elevator, right? We didn't touch any of the elevator system. So that's why
but the elevator itself is still working.
yeah, it was still working normally.
Yeah.
People would go in and out.
And you
So
had,
we
you had
basically
100%.
perform surgery in a moving vehicle.
Yeah.
Well, it's a remarkable story. I mean, it's a feat that that everyone should be really proud of. Can you guys help the audience understand? Because, I'm sitting on the blues side of the equation, and obviously I have a bias. But you're sitting on the partner side. You are the ones that are responsible to the end customer, Lift AI, to make sure that this thing works and it works flawless and you don't end up bricking devices. Can you help us understand how Blues was instrumental in making this happen?
Absolutely. I think it was paramount to have Blues. And then I guess I'll start by saying you need to try to set yourself up for success from the beginning. There's some things that we can fortunately change, and the paradigm shift is here that normally when people think about full firmware stack, changes, they are not done conventionally the way we did it. But there are some things that we definitely cannot change, like the note card itself. Had the device not used the right components from the beginning, this would have been impossible. So I think that's one of the main reasons why Blues was instrumental. The note card, and not only that, but also the platform itself, the entire, as you described it in the beginning, Jim, ecosystem of the note card communicating with Note Hub, providing us the opportunity to have a reliable way to manage this fleet of, or multiple fleets, in fact, of hundreds of devices across the nation. And to be perfectly honest, me being working on it on a daily basis, I had to say, with different moving pieces from the device itself, the hardware, the firmware, data coming into Node Hub and then going to a different system where the customers get to see it, by far the part of the process in this workflow that I just described that has the least amount of issues for us over time has been Node Hub for sure. So it gives us a good groundwork to work from, and a reliable piece of tech that really helps us to build everything else out of. So that's good.
If I may, I do have a slide that I think it can help. So I'll try to share it now. All right. Is it visible?
Yes.
Okay. All right. So this is a very simplified version of the system, but it helps to understand. So that is essentially, I have one of the Lift AI devices here. So inside, you will find a note card right there. This is the little note card and the carrier board and the MCU that is running the Lift AI application. So, but the beauty of it was the actual architecture of the Blues solution, because as you can see, this is a note card. It's connected to the internet and directly to the Note Hub on the cloud, but it's completely isolated from this block right here, which is where all the Lift AI application runs. So this is what we call the application MCU, and all of our application code is running here, right? But this is only this component of the full solution. We have what we call the business logic, all the algorithm is running there. It's collecting data from the sensors. That's where what we take care of, what we wrote. But after that, when we need to push this data out there, we pass it over. Literally, we just pass it over to the note card. And with one instruction, say, we want to publish this, and Blues then takes care of everything from the note card all the way to the Note Hub. So this is what allows us to actually perform the DFU, because with the help of the Blues team, we work in collaboration with the help of the Blues team, right? We made it so that not only we do what we call the outboard DFU, which would be device firmware update from the note card to our MCU, but we also needed to actually flash the whole thing, wipe the whole thing, right? Because in the application, the firmware stack has different layers. And typically when you do a firmware update, right, you update the application layer. In this case, since the original platform was a CircuitPython platform, we had to wipe the whole stack, including the bottom ones, the bootloader stack, which is not something typically you do remotely, right? So that would be the equivalent to having physically get the device, connect to it to your computer, and what we call flash it, which is wipe everything and load the whole firmware stack again completely, right? So instead of doing that through a host computer connected to it, we use the note card as the surgeon to perform that that operation. So we had to work in collaboration with the Blues team. So they actually work on the firmware that runs on the Notecard to help us enable that. So that way we could talk to it. So we started with instructions on the node hub. So this is the binary. This is what we need to push, right? The node hub takes care of all the communication or to the device, going from the cloud to the device. We push the firmware. The node card takes that and then starts the whole process and puts the MCU in the mode that is gonna it's gonna take the binary and do the complete wipe of the memory. So all this process takes about 15, 20 minutes tops. And it was pretty remarkable. And and let's say we were a little bit nervous when we started pushing the update because we testing in a controlled environment, everything went okay, but you never know what's going to happen when you have to push it out there on the wild, right? And hundreds of thousands of devices up there. If something goes wrong, then the stakes are pretty high.
Did you sequence the updates across devices in the fleet, or did you push the update to all devices at once? How did you structure it?
That's a good question. We did sequence because we had to do actually 2 device firmware updates because we had to update the firmware in the Notecard, which we can do. The Note Hub, the process that we can do that, and you guys issue regular Notecard updates, and we do that on a pretty much frequent basis. We did had one specific firmware that it was made for this operation. So there was a 2-step process. And the way we did it is that we utilized in the Node Hub, you can move your devices to different fleets. So we had a group of devices that were like pending for the Node Hub, for the Notecard firmware update. So we put it there, and in batch, we can select all of them. And with one click, essentially say, okay, let's push this update to this subset of fleets that we want to move. And then we wait for the fleet to be updated completely. We can see in real time how the devices have been updated. Once the Notecard firmware was updated, then we moved those group of devices to another fleet, which was like host firmware update, lift day update, and there we push our application update. So that's why it takes that process takes 10 to 15 minutes to go through all of them. So it's relatively quickly, and it was painless using that feature in the Node Hub.
Yeah, it really made I don't know who came up with the title for this chat, but when I look at it, future-proof your fleet without touching your hardware, that story really does tie to the title of this conversation. Because who knows what's going to change in the future, There was a question, I think, in the Q&A here from Luis. How does the brain transplant work with challenging cellular conditions, such as an elevator? Because there is a lot of potential interference or blockage of connections. Did you guys see any of that during this process?
Yes, definitely. There are sites that are more challenging on cellular connectivity than others. So that's another thing that we can see the data coming from the Notecard. So we can see how the cellular coverage is. And we had like one huge dashboard where we can see, so we have the data on the Node Hub, but we also have a server where we run a dashboard where we pull the data from the Node Hub and we pretty much visualize it. And we made one specifically for the process of the fleet firmware update. So we can see in real time, pulling data from the Node Hub that it was coming in real time, we can see how the performance was. So we can see clearly what are the devices that have weak signal strength. And we can see a correlation in time. That's why I say, because I know we've seen the data, if the signal strength is not the best one, it's going to take a little longer because the rates, the throughput are probably going to be lower or they need to retry. But the solution, the Blues solution allows for that to happen. And since we are passing a binary file, it's not too big, so we don't need a whole lot of bandwidth. Eventually, it's going to get there, right? So the protocols allow for retries or wait for a better conditions. It gets through, right? As long as the device is able to at least connect to the network, it's going to get there. Another thing we notice, right, is that the nature of this specific application, right, the elevator shaft, pictured like a really tall building. If the elevator like is in the bottom floors, it's going to be like buried with the steel and concrete. So that typically the coverage down on the bottom floor is not the best one, but when it goes up, sometimes we can see that a better signal gets picked up, and the DFU it's able to go through, and it's enough. Sometimes it's enough to just that's what we needed, and eventually it'll get there. So
For for those of you that are listening that are engineers or developers, and you're curious about some of the things that we've talked about here today, there's a wealth of information on a site that you guys that's free access for you. It's called dev.blues. And so if you're technical and want to learn more about features of the note card, the interfaces to it, how you write code in JSON, how data moves around, security, the functions of the note hub, all of that is on dev.blues. And there's a wealth of information there. It's actually really, really good documentation. There's also a community out there that is constantly posting stuff about cool things like this that they've done. This is not a activity that I would say is normal in most deployments, but it is very possible. And so that's because of the architecture that was put together. I want to shift the conversation a little bit from the technical piece to the business context here. You've got this customer, we've talked about who they are, that had to make this change to their devices. You guys were close, you guys were on the ground with the customer in this process, and they probably had a lot of conversations with you why they were doing this. What was the business impact and the business benefits that they got once this process was complete?
All right. Well, we've mentioned high level some of the business benefits Lyft AI especially got out of this process. The fact that we didn't need to physically access the elevators or the devices led to a whole bunch of business benefits. Mainly, hardware costs were reduced because since we were utilizing the original devices that they deployed from version, let's say 1.0, they didn't have to replace them with new ones. It reduced the production cost significantly. And doing it over the air also made that we didn't have to send technicians, as you discussed in the very beginning, Jim. Costs for physically having someone access the elevators are high. That said, since there was zero downtime operationally, the elevators kept working during working hours or work hours, 9 to 5, etc. The customers of Lyft AI's customers, we call their clients, were also not impacted. So there was no business cost there. I'd say those are mainly business-wise the benefits they found, and as well, of course, having their solution being prepped for future updates, which essentially limits the number of or the investment that they may have to do in the future now that they have a firmware that is more future-proof, modular, easy to scale, and more deterministic in its approach to generating data. I think one other thing that I'd like to mention is originally the device wasn't able to collect data, and now that's within sites. So of course, data nowadays is very important, and them having the capability of collect that data allows them a plethora of new options, utilizing our name AI training, a new system to do things beyond what they are capable of doing today, and that would have been impossible with the original device and the original firmware. So that's also a very big benefit looking forward.
I had a conversation, this might be interesting to everybody listening. I had a conversation with a company that was building devices that did air quality monitoring, humidity controls, a bunch of things that their device did. And they made a comment that they said, like some of the cell phone companies out there, we will force, if a device doesn't die within a certain amount of years, say 3 years, This was like this guy was telling me this. He goes, "We will force it to die."
Oh, wow.
And I thought that was like, I don't know, I didn't sit well with me. And then I hear this story about Lyft AI, who has these devices out there. And I guess there were a lot of things they could have done. Okay, they could have done nothing and just said, hey, the device is what it is. They could have sent new devices out instead of like updating the old ones and said, hey, we're just going to send all of these customers new devices. Here's the cost for that. Somebody goes and does the install. There's downtime with that whole process. Or they could have sent technicians out to actually like reflash the entire device. But in this situation, they did none of that. They actually like preserved the initial investment, not only for themselves, but for their customer, in a highly efficient way that set them up for the future. So I thought the contrast between this other story that I heard is like, we will force the device to die and force people to pay for a new one, to this situation where it's like, no, we will keep the device alive. We will give it a new brain. Couldn't be more further apart. And I just thought that was kind of interesting as I thought about getting ready for this conversation. You know, everybody that has devices out in the field, ideally, unless they're literally swapping devices out and sending customers new ones, will do over-the-air firmware updates. How do you guys see this helping in situations where, you know, technology is evolving so fast now? It seems like every day there's a new AI function that is rolling out that was like better than the one we used last month. And we're seeing this in real time. Like things are moving so fast. Regulations change. Regulations drive down into industries. This process that you guys have proven that works. Any comments on that aspect as it relates to not just updating your RTOS, but what this means from a business perspective in remaining competitive in regulatory environments or landscapes that are changing?
Yeah, that's a great one because there's a thing that everybody involved in product development understands that hardware is hard, right? That was the thing, like compared to software development life cycle, like the hardware development life cycle is really difficult and hard. It's way longer, right? You typically you couldn't just push an update and fix whatever problem you have on the field as you can do with a software update. There are companies that do software updates on a daily basis, just like iterations pretty quickly, right? On hardware, that was not the case, still is not the case. However, advancements in embedded systems and hardware, like actual physical MCUs, are kind of making that a little bit, that gap more narrow. So we're getting closer to do more quicker update cycles, right? And be prepared for iterations to be more fast and quickly than before. So uh, I guess the biggest benefit of that is that we can adapt quickly now. When you deploy IoT out there, IoT fleet hardware out there with these new platform solutions, the way we architect them with the tools that we have, we can iterate pretty quickly compared to what even 5 years ago, 10 years ago was not. Some things that we're doing today were like completely impossible to perform 10 years ago, right? Now we can move quickly. So that allows like people like Rob in Lyft AI, they can think about their market, their vision, where do we want to go, right? And people like us, it's like, okay, right, let's take those inputs and now we can plan that to get there. How do we plan that? And we have the tools to get there. So we can act fast compared to that. So if there's a new feature, and for instance, we moved from Circuit Python, which was something, let's say, quick and dirty to get you out there, to a firmware that is based on Zephyr RTOS, which is pretty much it's becoming the Linux of embedded systems. It's out there, it's everywhere. Big companies are using it, but it allows you to design your firmware, architect your firmware that it's flexible, right? You can add features on it, you can grow, you can scale. You have the security embedded in the system. So it allows you to move quickly because all of that is there. So now if we receive, oh, we have a new feature that we need to try, like Carlos said, we can now have a way to enable data collection on devices that couldn't enable data collection before, and that would allow, new technologies like AI to train this machine learning on the edge with the data that we collect on the same devices that we can run the models now. So we can improve algorithms in the case of elevator, anomaly detection, trip detection, floor detections, all of that. Now we can work with those new advancements because we laid this foundation with this architecture and these tools.
Yeah, this leads into there are a bunch of questions. We'll get to many as we can. I know we only have a couple minutes left. Some of them we have kind of been answering through this. One of I'll just tag two of them together, which you touched on slightly, Albert, which is why did you choose Zephyr? And the second question is related to security. Like, hey, if you guys can lay down a full-blown RTOS on the device, what would stop somebody else from doing it? So let me tag the Blues side of the security, and then I'll let you address the Zephyr and the security side. That's probably all we're gonna have time for. Just real quick on the Blues side, on the note card itself, it does have a secure element on it. Keys and certificates get flashed on that at the point of manufacturing. No human hands touch keys or certs. Okay, so that's item one. Item two is that all of the data that are collected from the device onto the note card are fully encrypted. Number three, they are transmitted to the cloud over private VPN, a private VPN tunnel for the customer, and TLS. They do not touch the public internet. So I'll just kind of leave the Blues security side there. Our CEO and founder is deep into security and has been throughout his career. It's a core staple of what we do, but I'll turn the last bit of time over to you to talk about Zephyr and security.
Absolutely. So why do we choose Zephyr? Like I said, it essentially is industry momentum. It's not because we know how to develop in Zephyr. It's pretty much the industry is moving towards that direction. It's becoming the Linux of embedded system. There's the hardware flexibility. It runs on multiple platforms, right? It is production ready. So that was the big difference compared to the CircuitPython one. It's built for commercial deployments, not a prototyping thing. It's extremely resource efficient. So it's optimized for low power, memory constraints. There's a active ecosystem. Major companies are contributing to the open source project. It is pretty much future proof. The steering committee is making sure that there are regular updates and growing feature set of towards the security. And in our case, we do have deep expertise and Zephyr knowledge, as we are also leaders and active contributors to the project, right? So in terms of security, so there's a Zephyr, and we follow all the best practices to keep updated on securities. There is a new regulation that is coming soon that we have been preparing for the EU, which is the Cybersecurity Resilience Act that is going to be in effect in the next couple of years in the EU. So Zephyr is getting prepared for that. So we're going to have all the tools that we need to make sure that products that are running Zephyr are in compliance with that, with all those regulations. So in short, we do the best practices. We keep up to date with all the new regulations, and we are working with the foundations of a huge open source project that is right on top of that. Is one of the direction and principles going into security for embedded systems.
Wonderful. Well, I think we are at time. For all those that contributed to preparing for this fireside chat, there's a lot of people that put a lot into getting these things ready, getting people invited, putting content together. The Croxel team for your time and preparation here, and honestly for your investment in time and the relationship, not only with Blues but with Blues customers. Like that means a lot to us. We're really appreciative of you guys, and love your work. So thank you all for attending today. There were a lot of registrants for this webinar. this topic like was hot. So thank you all for coming and listening today, and there'll be more to come. See you soon.
Thank you. Appreciate it. One last
Thanks,
thing.
Jim.
We're open to hear anything. Anybody has an interesting project or something that they're considering blues, please reach out. We're always happy to talk to anybody.
Excellent.